At night time, we obviously lose the visual reference points we have in daylight. Headlands, mountain tops, and all the other landmarks we see during the day are lost to us. Thankfully, the marine authorities strategically place lighthouses and buoys with lights for us to use in the dark. As mentioned earlier, they're all shown on our charts with magenta teardrops. Each one in an area will display its light in a unique way, and that's what we're going to discuss in this section.
There is a simple code used on marine charts to inform us of precisely how a light will be displayed. For instance, this tells us that this lighthouse shows a light that flashes 3 times within a 20-second sequence. Light sequences define the total time taken before the sequence begins again. So in this case, the count starts at 0, the light is displayed twice, and then the sequence begins again after 20 seconds. There are many different ways of displaying lights, and we need to learn the abbreviations used on the charts. F means a fixed light. In other words, it's on all the time. If it's coloured, the abbreviations R for red, G for green, O for orange, or Y for yellow are used. So this now tells us that this is 2 red lights displayed vertically. If no colour abbreviation letter is shown, then the light colour is white. This means a light that flashes with a length of flash of approximately 1 second. This means it's a long flash with a length of light of approximately 2 seconds. Q means a quick flashing light, showing for approximately 0.8 of a second, and VQ, very quick, just 0.6 of a second. Any of the above can be combined with further sequence information. For instance, this means a quick red flashing light that displays 3 times within an 18-second sequence. The other abbreviations tell us that it is 32 meters high and the light has a range of 8 miles. Here are 2 more light sequences you will encounter. ISO means a display with equal lengths of light and dark. So in this example, with a total sequence length of 8 seconds, the light will be on for 4 seconds, then off for 4 seconds. OCC tells us that this is an occulting light. In this case, the length of time the light will be on will be longer than it is off. So in this example, it will be on for 8 seconds and off for 2 in its 10-second sequence. Some lights can also show different colours depending on the angle they're viewed from. They're called sector lights. In our example here, this light shows red when viewed from here, white when viewed from here, and green from here. It also has an obscured area and therefore cannot be seen at all if viewed from here. All lights have a minimum visible range of 3 nautical miles, even if there's not a range given for it on the chart. However, due to the curvature of the Earth, that does not mean it can necessarily be seen from that far away. It all depends on the height of our eye above sea level and the height of the light itself. Almanacs provide simple dipping distance tables for calculating at what distance we can see a light. The light we are interested in has a height of 16 metres and a published range of 12 miles. We have estimated our height of eye above sea level to be 2 metres. If we then draw a line across here for the height of the light, we can see that in reality we will not be able to see it until we're 11.2 miles away.
Once correctly identified, the lights on lighthouses and buoys can be used for navigation in just the same way we use mountaintops, headlands, towers and churches during the daytime.